today we're going to go over the standard form of an ellipse. Okay. So we go ahead and draw it. Okay, so let's say if we have, it's supposed to be an ellipse, but it kind of doesn't look like one. Okay, so this one's elongated vertically, and this one's elongated horizontally. Let's clean that up a little. Okay, so let's say if we start at our center. Okay, now your center, just like in a circle, your center is HK. Okay. Now what if we go from the distance from the center to the actual circle going side to side, at least on the vertical. Okay. Well, we'll actually call that B. So B equals the distance from the center to the graph. Okay. Now for an ellipse, the shorter part of the ellipse is actually called the minor axis. Now if we go from the center to the long part of the ellipse, that's called the major axis. Okay. Now for this one, B, remember that's your minor axis. So the distance from the center to the graph, we'll call that A, and that's your major axis. Which is the distance from the center to the graph. Oh, sorry about that. Okay. So here, right between the center and the focal point, in the center, you have your focal points. So FOCAL. Or when you have more than one focal point, just foci. Okay. And really it's the same thing here. The only difference is your A and your B's are switched around. So the distance from your center to your shorter end, that would be your B. Notice here it's vertical, and here your B is horizontal. That's your minor axis. Then the distance from the center to the elongated version of it, that's A. So remember, B is your minor axis, and A is your major axis. Okay. Okay. So you have your focus points there, or your foci. Okay. And it kind of gives us, we're going to kind of ignore all of these steps to finding the formula and all of that, because that'll burn 15 minutes and you'll never use all of those steps and proofs anyway. We're going to go right to the formula. Okay. So if you have an elongated vertically, or if your major axis is vertical, move that up. Uh-oh. Okay. X minus h squared over b squared. Clean that up a little bit. Plus y minus k over a squared equals 1. Oh. That's your vertical ellipse. Okay. Now, if you have the horizontal ellipse, just x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay. So if you notice, wherever your major axis is, so for the horizontal, your major axis is A. If you notice, that's where your y is the A. So here, your major axis is vertical. So that's why your A is now under the X. All right, so that's how you would kind of graph your, I guess you could say your ellipse. So remember, your center is HK. All right, so let's say for, oh, you want to still write it? I'll leave that up for a few seconds. Okay, so let's say, for example, if we wanted to graph the equation of the ellipse, say 25x squared plus 4y squared plus 100x minus 24y plus 36 equals 0. Okay. So remember, here we have to put it in the standard form in order to find our h and our k and our center and our a and our b and all of that. Okay. So remember, for this one, the first step, you have to put all your x terms next to each other, the y terms next to each other, and all of the constants, just take it to the other side. Okay. So first, you're going to rearrange them, which means 25x squared and 100x will be next to each other. Four y squared and minus 24y will be next to each other. And the plus 36, you're going to subtract 36 from both sides. So it's going to equal negative 36. Okay. So now, because we have a coefficient in front of the x squared and the y squared, we have to factor that out. So we're going to take the greatest common factor of those two and the greatest common factor of those two. Okay, so here you can factor 25 out of both of those. So you have 25 times x squared plus 4x, plus you can factor 4 from both of the y terms, and that leaves you with y squared minus 6y equals negative 36. Okay. So now you just have to complete the square for both of these.
I have a question.
Sure.
Like, for factoring this, we can't take it like both of the side as a 25x and 4y and take it as a x plus 4 and y minus 6.
X plus 4, y minus
And
6.
because on there there's a 25x square
Mhm.
and plus 100x.
Mhm.
So we can take it as a 25x. So that's going to be x plus 4.
Oh, yeah, I see what you're saying. I probably miscommunicated that a little bit. You want to factor out the largest number. You want to leave the variables in place. So that was me mistakenly. So instead of the greatest common factor, you just want to factor out the number. So, or a common number. GCF was a little bit vague. All right, so now you're going to use the completing the square for both of those terms. Okay, so we know for this one, a is equal to 1 and b is equal to 4. And write that a little bit closer up there. So a equals 1 and b equals 4. And for this one, a is equal to 1 and b is equal to negative 6. Okay. So just rewriting it, give it a little bit of space. So you have 25 x squared plus 4x, give it a little bit of room, plus 4 times y squared minus 6y, give it a little bit of space, equals negative 36. Okay. So now to complete the square, move that over some. Remember, that's b divided by 2a squared. Okay, so that's 4 divided by 2 times 1. 4 divided by 2 squared, which is just 2 squared. Remember, you're going to remember that value, which is 4. So that means we're going to add 4 here. But you're actually going to add something to that side, but it's not going to be 4. Because here, if you look at it, if you have 25 times 4, you technically added 100. So since you added 100 here, you have to add 100 here. Okay. Now, you wouldn't have to worry about that if you didn't have to factor out that 25. If you had just x squared plus 4x without that 25 up there, you wouldn't have to worry about it. But because you had to factor out that 25, you now have to take into account that if you distribute that 25 back, it would become 100. Okay. Since 25 times 4 equals 100, add 100 to both sides. I mean, add 100 to the right. Okay. And we do the same thing with the y terms. Make a little imaginary boundary there. So our completing the square, remember that's b divided by 2a squared. Here our b is negative 6, our a is 1. So that's negative 6 divided by 2 squared, which is negative 3 squared. And you want to remember that value, which is 9. So we're going to add 9 here. But remember, we have 4 times 9. So really by adding 9 in here, we added 36 to this side. So we have to add 36 to this side. So 4 times 9 equals 36. So add 36 to the right. Okay. So this one, move this up a little bit. If we rewrite it, we have 25 times x squared plus 4x plus 4 actually becomes x plus 2 squared. Plus 4 times y squared minus 6y plus 9 is actually y minus 3 squared. Equals negative 36 plus 100 is just 100. Now remember, your ellipse is equal to 1. It's x minus h over a squared and plus y minus b over b, and it's equal to 1. Okay, so what we're going to do here is going to divide each term by 100. Okay, so that gives us 25 over 100 is 1/4. So it's x minus negative 2 squared. And instead of over 4, we're going to make that 2 squared. Plus y minus 3 squared. 4 over 100 is 1 over 25. And we can make that 25 5 squared. Equals 1. Okay. Now the one thing about an ellipse is A is always bigger than B. If you go back to our graph, our major axis, A, is always bigger than our minor axis. So even for this one, our A is always bigger than B. Since A is bigger than B, we can automatically know that A is equal to 5 and B is equal to 2. Okay? So just by our A being under the Y, we know since that's the bigger number, it's going to be a vertical ellipse. Since the Y term, or A is under the Y term. Well, I guess you could say A equals 5 under the Y term. Okay. And we can also tell here that our H and our K will tell us our center. So we have H equals negative 2, K equals 3. So you have negative 2, 3. Okay, so we have our center. So we know exactly how our graph is going to start out. Okay, so we have our A is equal to 5, so we know from our center how far up and how far down we're going to go. And we have our B is equal to 2, so we know how far left and how far right we're going to go. Okay, so we'll go ahead and graph it on the next page and put all of that together. I'll kind of leave that up here. Okay, so we know that's a vertical ellipse, so we can go ahead and make that graph. Okay, so we have A is equal to 5, B is equal to 2, and the center is at negative 2, 3. Okay, so if our center is at negative 2, 3, let's go negative 2, negative -1, -2, and let's say this is 3. Okay, so our A is going to go up 5, so you're going to go for 5. Move that up a little bit. Okay, so this actually becomes -2, 8. Because remember, that's your A. And we're going to go down 5. And that's, make that a little bit more. That actually becomes -2, 3, 2, 1, 0, -2. Okay, and our B, remember our B is equal to 2, so this goes to 0, and this goes to -4. Make that a little bit lower. -2, -2. Okay, so really in between there we can, yeah, I knew that was going to be off, but you hopefully get the idea. My drawing is never the best. But actually it should look like that. All right, so like I said, this is your center at -2, 3. All right, so any questions on that one? All right. Oh, I'm still writing. Okay, let me straighten that up a little bit. I just feel bad leaving it like that. Hopefully that's not as horrible. So it should look something like that. There we go. It's not as bad. Okay. So now we're going to do the same thing, but we're going to do it for a parabola, which we've done a little bit, which are quadratics. Oh, a little bit. Okay, so we know that for a parabola, actually I'm going to skip the proof and all that and go to the general formula. Since the proof isn't going to be on any exams anywhere. There we go. Okay, so here, we have x minus h squared, 4p y minus k, and I'll explain each individual letter. And you have here y minus k squared equals 4p x minus h. Bless you. Okay. So here your focus point It's called P. That's your focus point there, called P. Now the ellipse had two, but for a parabola you only have one. And what the focus point does is, which won't be on the test, but we're going to kind of show what it, oh, sorry about that, let me move that back there. If you have a parabola, so let's say if you have your focus point, let's say you have this line here, we'll call a directrix. If you go the distance from your focus point to your directrix, we'll mark that as a point there. So let's say you have another point where the distance here and the distance here are the same. So we'll mark that as a point. So let's say you have another point where the distance from the focus is the same as the distance from the directrix. So you have a point there. So now you do that over and over where you have a distance from the focus is the same as the distance from the directrix. And it keeps going and going and going like that until when you connect all the dots, you actually have a parabola. Okay. Like I said, you won't need it, but it was one of those things where if you were thinking, I wonder what the focus does, that's what it does. Oh, let me add that to the notes. Okay, so you know that if your P is greater than 0, or if you have a positive value P there, then your graph opens upward. And we know if your P is less than 0, it opens downward. Okay. Now your focus can actually be found using the formula H K plus P. And the directrix is actually the formula y equals K minus P. And you can get your K and your P just from your center. I mean your K from your center. Remember that? Not center, vertex. I'm thinking of the previous one. Which is HK. Oh, sorry about that. Move that up some. Okay, so this is your vertex just like before. That's your HK. Okay, so now if you have your horizontal parabola, remember this is your vertical, and this is your horizontal. This one has now you saw the different formula. You still have HK as your center. I mean, why I keep saying center, your vertex. But in this case, if P is greater than 0, it opens up to the right. But if P is less than 0, it opens up to the left. Okay. Now your focus here is H plus P, K, and your directrix, H plus P, H minus P, sorry about that, X